Okay, we already cover most of the attacks which can affect our network and also the machine in our network, malware and also other type of intrusion. So now we look into countermeasure parts. What I mean by countermeasure here is more on how we protect our network and also our infrastructure, include the asset and endpoint as well. So how to prevent it? First of all, we need a policy, information security policy. So each organization must have a clear policy or clear security policy. So from that policy, we can derive what type of access that we can allow to the user itself. Okay. Then we need awareness. Mean all the user must aware about their responsibility, their access capability and so on, so that if anything happen to them, they know what they need to do, what are their responsibility and what are their uh, accountability. Okay, awareness about how to protect themselves, how to protect their uh, host application, their password. This kind of awareness must be in place, not only for end user but for top management, to IT and staff and all the users. Then we need a vulnerability mitigation. In this type of countermeasure, we need to ensure that uh, organization has periodically or frequency of vulnerability assessment and penetration testing, so that we can identify any vulnerability in specific level of our infrastructure, in network level, for example the routers, switches, then our network tools, network security solution, the host itself, application and so on. So all those things must be conducted periodically, include the audit, VAPT or VAPT, vulnerability assessment and penetration testing, one of it, and then they need security audit to ensure all the vulnerability can be disclosed and then can be patched. Then threat mitigation. If we identify the vulnerability, we need to look into the possible threat, so then we can mitigate that kind of threats before it's happened. Similarly, we can say that we need the risk assessment and risk management, so that we can analyze what type of attacks can be occur and then how to mitigate it. Okay, one of the first countermeasure that should be employed is to ensure all systems are as current as possible. Mean here, we need to ensure our system, all the servers include the operating system, the firmware of the hardware, all updated with all patches apply in order to reduce the number of vulnerabilities that might be exploited on the system. Because most of the time, the attacker will find the current vulnerability which not has patches, so that it can be easily penetrate without detected by maybe the malware, anti-malware or IDS. This is considered as zero-day attack. Then next is to set the appropriate access control on the application and data stored on the system. So this is system level or application level. Access control in operating system in application. Same thing like what we discussed earlier in network access control. I give you also some exercise. Uh, if you still remember in AWS part, it's more on cloud access control. So all this component infrastructure, IT infrastructure has their own access control mechanism. Please ensure if you are the one responsible of security, you see all the component must be appropriately configured the access control. The third common propagation mechanism which target user is a social engineering attack. So this can be countered using appropriate user awareness and training. So if your user in organization aware but the technique used by the social engineering attacker, then they know already. So this type of attack can be happen, and they will be careful every time they receive this type of approach or method by the attacker. Similarly, in email, the phone calls, and others. This security awareness must be in place. Nowadays, if you look into the compliance standard like ISO 27001, PCI DSS, HIPAA, security awareness part of their compliant requirement. So most of the time, your organization will need it. Okay, the security awareness. And then now we look into the specific countermeasure approaches for malware protection. So if prevention fail, like our awareness is not effective enough, the access control not effective enough, then we need to go in technical mechanism which can be used to support the following threat mitigation option like detection, identification of the malware or attack, and how to remove it. So detect, identify, and remove three main uh, mitigation option. Then the requirement of for effective malware countermeasure, normally they have generality. Timeliness mean how much time they require to detect and to recover from the attacks and to remove the malware if possible. Resiliency, minimal denial of service cost. For example, if affected and this machine or the system affected, we need very minimum downtime. That's mean denial of service cost. Downtime must be minimum. Then transparency. We need the solution that can transparency uh, transparent to the user, so the user know what happened and how to act based on the situation. And then they require also the global and local coverage. If you buy a solution or subscribe to the solution, you need to ensure that they have the support from global perspective and local perspective. Let's say that maybe this solution from Russia or from Germany, so you try to find, is it they offered you in Malaysia, so that we need the support from Malaysia perspective as well. Sometimes they say that they can provide global coverage or global support, but when we call them, they will have a very difficult situation to help us. This happened previously. I still remember when uh, we buy last time my ex university we buy PC from HP if I'm not mistaken, but the support call a support center in India, and then when we talk about what happened, they didn't understand. Then they talk also we didn't understand because of the slang maybe. So that's a difficult part. Try to ensure they have the local support that can understand our culture, our uh, way of doing something. Okay. Other than that, the host-based scanner is one of the protection measure as well. They got antivirus software. This is the common one, right? Very common. Most of us know what is antivirus. Non-IT also know what is antivirus. So you see here they got first generation until fourth generation of antivirus. Antivirus is one of host-based scanner. It's not only that we have HIDS, FIM, also considered as host-based. But the most common one, most popular one is antivirus. You see, first generation only simple scanner. Just require malware signature, then identify. Make the match. Scan, then the match with the signature. Then the second generation, they come up with heuristic scanner, which using heuristic rules to search probable malware instance. This one more advanced. And then they got also integrity checking. Like I said before, file integrity checking. They uh, what we call host, which mean the block level or the disk level of integrity checking and so on. And then in third generation, they have more advanced activity traps. They add on another capability of malware, anti-malware. So memory resident program that identify malware by its action rather than its structure in an infected program, so that they can scan the memory program. Then when the program execute, they will try to identify is it malware or normal program. In the fourth generation, full feature protection nowadays. That's why when you see the current antivirus, they embed, they integrates most of the security solution in one package. So you can have option you want to uh, subscribe with ransomware protection, rootkit protection, host browser based protection, a lot, right? Package consisting of variety of antivirus technique used in conjunction. Means they can use heuristic, you can use static and dynamic analysis, so that it can provide you more and more. And then some of the antivirus also now work in cloud base. So that you didn't require to install in your machine, they just scan your machine from the cloud. Other than antivirus, we have host-based behavior blocking software. Normally integrate with the OS and host computer and monitor program behavior in real time for malicious action. So based on behavior, the software then block potentially malicious action before they have a chance to affect the system. Sometimes this type of software also embed or integrate in anti-malware. Can block suspicious software in real time, so it has an advantage over antivirus detection technique, such as fingerprinting or heuristic. However, they got some limitation because the malicious code must run on the target machine before its behavior can be identified. It can cause harm before it has been detected. This is the limitation, because before the malware executed, then this type of software cannot detect because they didn't know the behavior itself. Then we have parameter scanning approach, which antivirus software is used on organization firewall and IDS. So they integrates together. Typically include in email or web proxy service which are running on this system. Also included the traffic analysis component of an IDS. Now they integrate together. Two type of monitoring software can be used. One is ingress, mean incoming traffic level scan, right? Located at border between the enterprise network and the internet. Later we can see example of how the deployment of this kind of uh, tools, security tools, in session 10. Okay, so how it works? It can be part of ingress filtering software of border router or external firewall. When you see the ingress, then you can imagine it can be located or can be deployed in the border router out or the external firewall. So we can have various or multiple level of firewall. And then second approach, we can use as a egress monitor or outgoing traffic monitor. So this can be located or deployed at the egress point of individual LANs on the enterprise network, as well as the border between the enterprise network and the internet, depend on our deployment model. So this designed to catch the source of malware attack by monitoring outgoing traffic for sign of scanning or other suspicious behavior. Because the malware itself now the is not only download and affect, but nowadays like the bot, right? When they affected our internal user, our internal machine, they will communicate again to the server, to their bot server, to their malware server or attacker server. So when the communication from our internal user to the external server owned by the attacker, this can be monitored as well as egress monitor. So from this monitoring, we can capture the pattern or the access destination, how it's work. Then from the pattern itself, we can detect this is part of the attacks. So that's why egress and ingress monitor is quite important both. Then we have parameter worm countermeasure. This is specifically for worm. You got class A, class B, and class C. Class A using signature based worm scan filtering. Uh, Class B they use filter based worm containment, and then Class C payload classification based worm containment. So classification normally they require like the more advanced monitoring techniques compared to only signature. Class D, they call it threshold random walk (TRW) scan detection. Then class E, rate limiting, and class F, they call it rate halting. So class F, for example, here approach. This approach immediately block outgoing traffic when a threshold is exceeded, either in outgoing connection rate or device connection attempt. They got some statistical measure so that they got threshold value, and if that outgoing traffic exceed it, they just block. It's considered abnormal traffic, then just block it. So this is the example of how they place the worm monitor. You see, from this is a remote sensor. You got honeypot, passive monitoring, correlation, patch this one. You got also the sandbox environment. So later on in the network protection tools, we'll cover IDS and also IPS with firewall. This is just an example of placement or deployment of worm monitor. Okay, that's for malware protection. Now we jump into distributed of denial of service attack. So this attack make computer system inaccessible by flooding servers, network, or even end user system with useless traffic. You know, like I said before, if the botnet or zombie they got group numbers of the affected machine, then they can launch more complicated attack like this DDoS attack. The effect also will more harm compared to DOS. Okay. So the resource consumed is either an internal host resource or the target system or data transmission capacity. So data transmission capacity more on the network bandwidth. This internal host more on the processor, memory. So this is example of simple DOS attack, DDoS attack. They got from the attack machine affected the slave server, uh, which we can call it as bot, we can call it as zombie, right? At the end, they launch more all the resources they have from the slave server will send a packet to the single targeted web server, which will cause harm for this distributed sync flight. This distributed ICMP attack we use, okay, will be more harmful. Type of sliding based DDoS attack, direct DDoS attack. This one, reflector DDoS attack. You can see what are the different. Direct, they just direct from the attacker to the zombie, master zombie, slave, then to the victim. But for reflector, they will go various direction, various path. But this is more difficult to detect the resource. Okay. Now we look into constructing the network attack. The first step in DDoS attack is the for attacker of infect number of machine with zombie software will ultimately be used to carry out the attack. Discussed earlier, DDoS only they required infected number of machine, so that machine can become the zombie and the slave. Then they use that slave resources to attack the target victims. So this is essential ingredient software that can carry out the DDoS attack. Nowadays they can get it from numbers of attacker website. You can buy, you can get freely, and then they try to look the vulnerability in large number of system which can be affected, so that system can be used as a zombie. Then the strategy to locate vulnerability machine or the vulnerable machine, they use scanning. This is how the penetration will be used. Information gathering to look vulnerability of the machine. Then from that vulnerability information, they can launch and exploit, launch attack. Scanning strategy, random, hit list, topological, local subnet, depend on the targeted victim they want. But they require some work before they conduct or they perform it, to ensure the target victim can be harmed, can be attacked easily. So that how can we protect from this kind of attack? We have 3 lines of defense. Normally, first we can use attack prevention and preemption. Means before the attack comes, before the attack happen, we try to prevent it. This mechanism enables the victim to endure attack attempt without denying service to legitimate client. And we can preempt or we can prevent it. Attack detection and filtering. During the attacks, we need to detect so that we can respond immediately. If we didn't detect, maybe the harm or the damage will be more, will be worse compared we detect earlier. But if you can prevent, it's better than that. And then attack source traceback and identification during and after attack. Once we detect, we can look into the source of attack. We try to identify the attack source or the attack originality, so that we can use that information to block or to configure our network IDS, network firewall, and so on. So this is attempt to identify the source of attack as first step preventing future attack. There will be like a cycle. So prevent, detect, and trace back. This is the countermeasure. So for the next chapter, we will look into the network protection measure or solution, IDS, IPS, and firewall. So this is summary for this chapter. We already discussed about malicious software, the propagation technique, the payload itself, the countermeasure for malicious software, and then DOS attack, and also the countermeasure of DDoS. Okay, thank you.